Senyum. much. His Excellency, Dean of School of Postgraduate Studies, Diponegoro University, Dr. Arbi Sularto, SH, M.Hum.
His Excellency, Vice Dean 1 of School of Postgraduate Studies, Diponegoro University, Professor Dr. Hadianto, MSc.
Her Excellency, Vice Dean 2 of School of Postgraduate Studies, Diponegoro University, Professor Dr. Tri Retnaningsi Suprabowati, MFSc.
Honorable keynote speakers,
Academic Society of School of Postgraduate Studies, Diponegoro University,
distinguished participants,
ladies and gentlemen.
good morning and welcome to the 7th International Conference on Energy, Environment, Epidemiology, and Information System 2022.
Organized by School of Postgraduate Studies, Diponegoro University. The theme for this conference is Reconciliation of Energy, Environment, Health, and Digital System after the COVID-19 pandemic for global prosperity.
My name is Alif Lukman Wijaya and my partner,
Filomena Larasati. It is an honor for us to lead this event as the Master of Ceremony. As the matter of information, the 7th ICENIS 2022 will be held on August 9 to 10, 2022. There are 2 sessions on each day, the main session or plenary session, which we will be attending soon, and the parallel session, which will be held in the afternoon.
Excellencies, distinguished participants, ladies and gentlemen, please rise for the national anthem, Indonesia Raya. Thank you, and please have your seat. Ladies and gentlemen, to start the plenary session, we would like to invite Dr. Budi Warasito, SSI, MSI, as the chairman of the 7th ICENIS 2022 committee to deliver a welcome speech. Ladies and gentlemen, please welcome Dr. Budi.
Your Excellency, Dean and Vice Dean of the School of Postgraduate Studies, Diponegoro University, keynote speakers, moderators, Head and Secretary of the Study Program at School of Postgraduate Studies, Diponegoro University, all participants, ladies and gentlemen, good morning. Assalamualaikum warahmatullahi wabarakatuh. On behalf of the ICENIS 2022 Organizing Committee, I am honored and delighted to welcome you to the 7th International Conference on Energy, Environment, Epidemiology, and Information System, ICENIS 2022. With the theme is Reconciliation of Energy, Environment, Health, and Digital Information after the COVID-19 pandemic for global prosperity. This conference is expected to designate an interactive international forum to provide a platform for sharing and exchanging information on the latest research on energy, environment, epidemiology, and information system. Our technical program is rich and varied with 7 keynote speakers that come from 5 continents, from America, is Colombia and Canada, and then Australia, from Asia is Indonesia and Malaysia, and then from Europe, Switzerland and Netherlands. There are more than 200 technical papers split between 14 parallel oral sessions each day. The participants come from various countries and from all over Indonesia, consisting researchers, lecturers, practitioners, and post and undergraduate students belonging to various institutions. The last number of papers submitted to this conference indicate that the interest in the field of energy, environment, epidemiology, and information system gains a continuous rise in this country and worldwide. We are also proud to present the plenary speakers who are qualified to share their valuable information and knowledge at this conference. On behalf of the ICENIS 2022 committee, we wish all participants to have good attainment. We would like to acknowledge our high appreciation to the Rector of Diponegoro University, Dean of School of Postgraduate Studies, Diponegoro University, and the keynote speakers. Special thanks to Prof. Henis, who was present at Undip, and also other speakers who attend virtually. I would also like to take this opportunity to thank to the organizing team from the School of Postgraduate Studies, Diponegoro University, for all their hard work and dedication in preparing for this conference. As we have tried our best in conducting this event, we humbly realize that we may still be lacking in some parts. Accordingly, we would like to apologize for any inconvenience. I sincerely hope you will enjoy today and the next day of the conference and networking. With great pride, we present ICENIS 2022, and we wish you an inspiring time. Thank you very much for your participation. Assalamualaikum warahmatullahi wabarakatuh.
Thank you for the speech, Dr. Budi. Ladies and gentlemen, it is my pleasure to invite His Excellency Dr. R.B. Sularto, SHM, to deliver a welcome speech as the Dean of School of Postgraduate Studies, Diponegoro University, on behalf of the Rector of Diponegoro University to open the 7th ICENIS 2022. Ladies and gentlemen, please welcome Dr. R.B. Sularto.
Ladies and gentlemen, I inform you that the rector of Diponegoro University still being in Jakarta to attend national meeting. He asked for apologize for that and order me to deliver rector's speech in this opening ceremony. I will read the rector's speech, and his speech as follows. Honorable keynote speaker, Professor Dr. Lee Lam Hong from Quest International University Malaysia, Professor Henis from Australia Nuclear for Science and Technology, Professor Alfonso J. Rodriguez Morales from Institution Universitaria Vision de las Americas Colombia, Dr. Romeo van Mep from IUCN Switzerland, Dr. MV Wetkasamy Reddy from Institute of Research Hydro-Quebec, Montreal, Canada, Dr. ETPG van Engelhoven from University Lecture, Southeast Asia Linguistic, Faculty of Humanities, Leiden Institute for Area Studi SAS Indonesia, and Professor Dr. Tri Retnaningsih Suprabhawati from School of Postgraduate Studies, Universitas Diponegoro, Indonesia. All conference guests and participants, ladies and gentlemen, it is my great honor to welcome you to the 7th International Conference on Energy, Environment, Epidemiology, and Information System, or 7 ICENIS 2022. This is the 7th International Conference organized by the School of Postgraduate Studies, Diponegoro University, following the success of first ICENIS 2016, second ICENIS 2017, third ICENIS 2018, fourth ICENIS 2019, fifth ICENIS 2020, and the sixth ICENIS at 2021. With its remarkable accomplishment, this event is expected to perform annually. We are very much support this prestigious conference, with attended more than 200 participants. Diponegoro University is a prominent university located in Semarang, the capital of Central Java. Undip a strong tradition to carry our education and research as well as community service. The university has 11 faculties and 2 schools, which are School of Postgraduate Studies and School of Vocational Studies. We are also organizing 49 undergraduate program, 35 master program, and 14 doctoral program. Undip is one of the most well-known state university in Indonesia, with an international reputation for its teaching and research activities. In July 2020, 21, Undip ranked 8 in Indonesia according to QS World University ranking and ranked 9 in Indonesia in QS ASEAN University ranking. Undip, a scientific publication, indexes in Scopus total 7,790 documents, ranked 7 in Indonesia. Undip scientific publication indexes in Scopus is started on 31 January 2021. Ladies and gentlemen, the topic of the conference this year is reconciliation of energy, environment, health, and the digital information after the COVID-19 pandemic for global prosperity. This topic is very important since human security has been considered as the basic need for the country. The security in food, energy, water, as well as health in foundation of the country. The country must ensure that these needs are covered and secured for country population and through sustainable development goals set by United Nations. These human securities must be covered by each country in the world. Currently are facing global challenges, not only depletion of natural and energy resources, environmental degradation, but also pandemic COVID-19, which currently major health problem, which need to be tackled by every country in the world. It is our responsibility to develop better. I hope this conference will be an excellent platform to strengthen our concern and effort in confirming sustainable development for human security. Through this conference, I hope experts and researchers from all over the world could meet and share these experiences and knowledge to have explicit understanding regarding the complexity of the problem. I also hope this conference will present a memorable learning experience to all contributors and participants. It is expected that people presented in this conference are documented for our future reference and encourage further research in relevant areas. Thank you. Professor Dr. Yosjohan Utama, the Rector of Diponegoro University. I think is Rector speech, and with the Rector speech, I declare this conference are open. Thank you very much.
Thank you, Dr. Arbi Sularto, for officially open the conference. We hope this event will run as smooth as silk.
Ladies and gentlemen, please take your time because we will have a short coffee break for 5 minutes. Thank you. Okay, ladies and gentlemen, welcome back. And now we are entering the main part of plenary session. We will hear presentations from our speakers and followed by some discussions.
We're glad to have our speakers today, including
1. Professor Alfonso Javier Rodriguez Morales from Institución Universitaria Visión de la América, Colombia.
2. Professor Henis, former FNCA Climate Project Leader and Adjunct Professor at Undip.
3. Dr. Moglahali Venkatasharmi Reddy from Institute of Research, Hydro-Quebec, Canada.
4. Dr. Remco van Merm from the International Union for Conservation of Nature, IUCN, Switzerland. Also joining us today as the moderator for this plenary session, Professor Dr. Hadianto, MSc from School of Postgraduate Studies, Diponegoro University. Without further ado, we would like to welcome Professor Hadianto to lead the session.
Thank you very much, MC. Good morning, everyone. Good morning, everybody. I'm Hadianto from School of Postgraduate Studies, and It is great pleasure to be a chairman for this first session of plenary keynote speakers. We have two plenary keynote speaker sessions today and also tomorrow. And also I would like to welcome you all, the participants of International Conference of Energy Environment and Information Systems 2022. And ladies and gentlemen, since 3 years ago, or almost 3 years, we have been facing a global pandemic, COVID-19, and this pandemic has affected too many sectors, including energy, environment, and also health for human security. And this morning we have 4 speakers that we will discuss. How about if the pandemic is over, or we can say, how about if we have a post-COVID-19 within next few months? And this morning we have 4 speakers, including the first one is Professor Alfonso Rodriguez Morales. I hope Prof. Alfonso already joined this session. Good morning, Prof. Alfonso. Okay.
I am here.
Yes, thank you. Well, welcome. And then the second is Professor Henis. We are happy to have Prof. Heng join us physically to this conference. He is sitting besides me right now. He's former FNC Climate Project Leader and adjunct professor at Undip. And the third is Dr. Reddy. Good morning, Dr. Reddy.
Good morning to you all. Thank you. I'm around. Okay. Thank you.
Yes.
Assalamualaikum.
The last one is Remco van Merms. I think he will present his presentation by using video files. Yeah. The session will be divided into 2 parts. The first one is presentation by all the speakers. Yeah. For each speaker, maybe 20 till 25 minutes. And then open the Q&A sessions. And during Q&A sessions, maybe participants can raise hand directly to these discussions, or everyone can write chat also for the questions in the chat box. And don't forget to write your name and also the institution and to whom the question is addressed to. Okay. Without further ado, I would like to invite the first speaker, Professor Alfonso, and I would like to read the CV. Professor Alfonso Rodriguez Morales is an expert in tropical and emerging disease, particularly in zoonotic and vector-borne disease, and including COVID-19 and also monkeypox, and this current issue right now. He's president of the Publication and Research Committee of the Pan-American Infectious Disease Association, as well as president of Colombian Association of Infectious Disease. He's member of the Committee on Tropical Medicine, Zoonosis, and Travel Medicine of ICENIS. He's also vice president of the Latin American Society for Travel Medicine and member of the Council of the International Society for Infectious Disease. And since 2014, he has been recognized as senior researcher, Ministry of Science of Colombia, and he also professor of the Faculty of Medicine of Fundación Universitaria Autonomía de las Américas in Pereira, Risaralda, Colombia. He has a very high age index. Scopus age index is 50, and Scholar age index is 72. Okay, Prof. Alfonso, the time is yours.
Thank you very much, in first place, for the invitation for this conference. And originally, I was invited to speak much on COVID-19, but certainly on COVID-19, there has been a lot of discussion. And right now, I have been focusing precisely many of these presentations in this new emerging zoonotic disease that is right now spreading all over the world and is also connected with the realities that were derived from COVID-19 pandemic in terms, in the first place, related to factors. We have to mention initially that certainly we have not finished completely the pandemic of COVID-19. We are in a transition in this world regarding that with circulation still of COVID-19 that in fact is well connected from an epidemiological point of view to the matter that is another zoonotic disease. Coronaviruses are zoonotic pathogens that are located in multiple animals that may develop the spillover to multiple species, including the human being. And certainly, when we talk about this, we have to remember that certainly there are multiple factors that are related to the possibility of new outbreaks, new epidemics, new pandemics, and certainly at the same time, even with the cessation of the COVID-19 pandemic, right now, there are cases again that have been reported of the Middle East respiratory syndrome, MERS, of Marburg, Lassa, cholera, among other emerging and re-emerging infectious diseases in the world. Recently, also the problem of adenovirus hepatitis with co-infection or co-circulation with SARS-CoV-2, and due to multiple factors that we have to acknowledge in the interface of infectious diseases related to not only human, but also animal and environmental health, especially climate change and other related factors, we are experiencing more frequently emergent and reemergent vector-borne and zoonotic diseases, including the case that I will discuss about monkeypox. Certainly, as the Literature Nobel Prize states, death does not come with old age, but with the biblium. Certainly, multiple of these zoonotic and tropical diseases are neglected conditions from many points of view, and we are living on the edge of new emerging and re-emerging infectious diseases. Certainly, this monkeypox disease was discovered in 1958 in Denmark, not in Africa, as many people certainly would believe. And some years later, in 1970, was presented or reported for the first time in Africa in human beings. But from that time in the 50s, was observed in primates, in monkeys that were used for research in polio vaccine in Denmark, imported foreign from Singapore. And this developed this clinical phenotype of this rash, this presentation of pustule, vesicles, macules. And in fact, in that year was also discovered that this virus was able to infect human immune cells in cell cultures, but also the possibility to infect, at least experimentally, other animals, including rabbits as well, or later the discovery among rodents. Certainly, probably many outbreaks occurred before, but was unknown. And in fact, in this publication for Germany, it was reported that probably in 22 was 100 years ago, probably reported about this problem in monkeys in Brazil, in the zone of high Uruguay. And certainly many primates are involved in the possibility to be infected. But in Africa, where this is primarily in many zones, and zoonotic disease, which right now we are very highly aware of the possibility of multiple forms of transmission, other animals, especially rodents, are involved. In the last few weeks and months, there has been such a question as this one, if it's time to worry or to ignore this problem. And certainly in 2 times, the emergency committee under the international health regulations of the World Health Organization convened to assess if this was this was time to consider that this was an international emergency, a public health emergency of international concern, as was declared this on July 23. This DNA virus is well known and is less infectious, fortunately, than smallpox that was eradicated in the 80s, associated with the extensive use of the vaccine, fortunately with a lower case fatality rate that, in fact, until 2 weeks ago, it was considered or even not reported deaths associated to the current 2022 outbreak. But this problem is, as we mentioned in this editorial, a never-ending global emergence of viral zoonosis. And certainly many hosts are still to be defined, but more research is needed to understand what is really happening, because before 2003, when an outbreak related to imported pets from Africa, especially the prairie dogs, this was a condition that was not investigated. And this virus, especially located in the past in Africa, was divided from virological aspects in two main clades or two variants of this virus. But right now, the taxonomy indicates we have like 3 clades in which the clade number 3, especially associated to the lineage B1, is causing most of the cases outside the African endemic countries. In fact, in Africa, the DRC was the country that was most affected over the time, and certainly has been considered right now that there has been an underestimation of the disease importance, and probably one of the main factors or drivers that have been associated with the emergence of this condition, especially in Africa, is the cessation of the smallpox vaccination that provides a cross protection against monkeypox. And you will see that especially in forest areas from the DRC, there was a significant incidence in especially children causing this incident that right now is also reported not only among the LGBTI community, as is think by many people, but also affecting other age group and other population in less proportion. After 2003, outbreaks in United States with sporadic imported cases in United Kingdom, Israel, as well other, put in the public palestra and arena the conception of the importance of this disease, firstly with imported pests that introduced the problem related to illegal wildlife trade, as occurred, in fact, with COVID-19 in China, but also in United States in 2003, where non-sustained human transmission from monkeypox was established, but also only zoonotic. But right now, in 2022, there has been a lot of importance regarding global globalization of this disease due to travels and probably also to the evolution of this pathogen that now with genome sequencing, we are monitoring regarding the evolution and the diversity that right now is being observed in different lineage of this DNA virus. In May, over 2 weeks, 30 countries start to report monkeypox, especially in Europe, and this has been the increase in the number of cases that have been reported daily in different areas of the world. In June, we have less than 1,500 cases reported globally, but as you may see right now, this has increased significantly up to date, where we have more than 27,000 cases in more than 80 non-endemic countries in Europe, North America, Latin America, Middle East, Southeast Asia, among other areas in the world. Here in Latin America, this has been interesting because over the last few weeks, there has been a significant increase in the number of countries, as well in the increase of the number of confirmed cases, especially the case of Brazil and Peru right now lead in number of cases, and especially Peru, which is not so populated as Brazil, present high incident rates compared to other countries in the region. Most of these, obviously, right now has been demonstrated that this linked to gay pride parties, to other mass gathering related or not to LGBTI community. And this is important as a super spreading event, as we observe that also, for example, in respiratory diseases such as those caused by coronaviruses over the last 2 years. And certainly many epidemiological factors related to the sexual activity, mass gatherings, and other ways of transmission are now considered in the possibility of the risk of transmission of monkeypox in different countries. And this is still under assessment. But from a demographic point of view, it's important to say that most of these cases are occurring in adult males that are sexually active from 20 to 40 years old, and especially men who have sex with men presenting genital ulcer lesion, presenting eruptive disease in this area, and in fact, any rash. Most of the cases involve in self-limited presentation, but there is a number of cases that require hospitalization, may progress to complication, and even, as has been reported over the last couple weeks, in fetal outcomes, as has been reported in Spain, Brazil, Peru, and India, among other countries. A report a couple weeks ago from WHO, certainly most of the cases have occurred in male, but disease may also present in female, also in men who have sex with men, but also in non-men who have sex with men. In healthcare workers, occupational exposure may occur, and in a significant proportion of those cases is associated with sexual activity. Is an important thing because this is not related exclusively to the fact that the virus can be detected, as has been reported in multiple publications over the last few weeks, at sexual fluids. But the contact with lesions in the skin is the most important way for transmission. And this, in fact, can be, so far until today, considered as sexually transmitted infections, although this is related for multiple factors that are associated sexual behavior, previous or concurrent sexually transmitted infection. An important proportion occur among people living with HIV. And different reports that are growing right now are precisely showing the presence of the virus, for example, in seminal fluids, leading to the question if this can be considered or not as sexually transmitted infection, as there is a growing stretch of our evidence that are towards that. But it's important to not forget that the contact with the skin lesions is more important than that. Certainly, over the last few weeks, it's important to mention that the clinical presentation has changed from what's reported in the past, and this is right now a disease that may start with rash, with any genital lesion, with this kind of presentation among genitals that is presented in different parts of the body, in solitary or single lesions in different parts, but especially in genital, making the importance of differential diagnosis that are needed with this, including, for example, sexually transmitted infections that sometimes are concurrently, as has been reported in many publications. And this systematic review that will be published this week, this is improved right now, that are showing the importance of the clinical difference and the importance of the occurrence, for example, among HIV, but also, as I mentioned before, the importance to consider this in other populations, including in children, in women, among other populations where this is occurring. In HIV, when it's controlled, is not necessarily associated with fatal outcomes, as have been reported in multiple publications. This recently published in the New England Journal of Medicine, but has been considered the risk, especially in high-risk patients, something similar that we observed during COVID-19. We have to remember that multiple ways of transmission, close contact, droplets, skin lesions are important with this, and that in fact, other populations may be affected, that environmental contamination occurs, especially in the healthcare sector, but also in areas where patients have been actively in contact, for example, with towels, with sheets, and other environmental surfaces, for example, in patients' residents have been reported recently. Additionally to that, also, there is concern right now in which is the real proportion of asymptomatic infection that can be reported, but some of these publications, around 1%, are now under publications showing that this deserves more research. Differential diagnosis of this condition right now are wide. Multiple STI, as I mentioned, but even other eruptive disease, especially that are frequent in children, the measles, the case of chickenpox, but also, as we already mentioned, for example, secondary syphilis, herpes zoster, Coxsackie, as well, even other conditions such as the Stevens-Johnson syndrome, among others. Sometimes also presented with the possibility of simultaneous co-infection between monkeypox and HIV, syphilis, and other STIs. But remembering that sometimes the presentation would be very mild, as has been reported recently in different countries in Europe, as well in other regions. To ending, and this is among my last slide, we have to keep an eye, as we did with COVID-19, on the possible chronic consequences that monkeypox may arise. And some publications are right now suggesting that there is an increased rate, for example, for kidney cancer, among many other conditions. I would like to recommend, especially for people in healthcare sector, to consult the recently published guideline from the WHO about monkeypox, and to visit our journal Travel Medicine Infectious Diseases, where we have a special issue about reemerging human monkeypox with already 15 articles that have been published. I would like to finish with this last slide showing some of what is Colombia. This is the Lost City, a pre-Hispanic area. This is Pereira, where I live. And in Pereira, the poet Luciano Garcia Gomez usually says to welcome foreign people that in Pereira, there are not foreigners. We are all Pereirans. Thank you very much for your attention, and gracias.
Yeah. Thank you very much, Prof. Alfonso, for very interesting presentations. And I'm sure there are a lot of questions from the audience, but please wait until all the presenters giving their presentations. Okay, we come to the next presenters. Professor Hendrik Henis. I will just read his CV. Dr. Hendrik Henis is an environmental geologist with over 40 years of experience, educated in Netherlands in physical geography, quaternary geology, and applied physics. He immigrated to Australia in 1993. Hendrik to Australian Nuclear Science and Technology Organization as a leader in applications of nuclear techniques in environmental sciences. He became head of environment in 2016, a position he held until his retirement in 2021. He's also right now a young professor at School of Postgraduate Studies at Diponegoro Universities, and had a young position at the University Technology Sydney and the Australian National University. In 2010, he was visiting professor at the Royal Netherlands Academy of Science and the Arts. He also held position of leader climate project with the Forum for Nuclear Science Cooperation in Asia with the International Atomic Energy Agency. Okay, Hanks, time is yours.
Thank you, Budi. Okay, so this morning I will try and discuss the how we learn from the past, in order to better plan and manage our fragile ecosystems. I'll give two examples today, but given the title of the conference here, Energy, Environment and epidemiology, I think it's interesting to note that the current COVID outbreak and monkeypox and the stresses that we put on the environment by changing our environment, by ever increasing need for energy and food with a rapidly increasing world population. And the thing that strikes me over the last few decades that when we talk about changes to climate and the environment, that we often forget in the oral tradition what it was in the past. We have a very bad memory. Unless we write things down very accurately from year to year, we cannot learn from the past by just remembering. I tried this once with my own country, the Netherlands. I tried to remember which winters were really cold and where I could skate on the ice on all the canals around Amsterdam. And I made a list of years, and then I checked with the Bureau of Meteorology which years were really cold. And I think I had a score of less than 50% accurate. So that is my memory. And I think my memory is a little bit better than average. So still scoring less than 50% is not very good. So, but we can reconstruct the past by looking at certain sediments that have been deposited in the geological environment, like in lakes and in coastal lagoons. And they are like books to us. We open the book and we look page by page what happened at that spot from time to time. And as I will show you in my presentation today, there's two examples of very fragile ecosystems. One is on the equator, which is in the Galapagos, and the other one is in Antarctica, near the South Pole. And neither of these environments have a very long written history. So we really need to reconstruct the past to better manage those environments. So as you can see from my slide here, the Galapagos is hundreds of kilometers off the west coast of South America. It was only discovered by the Europeans some 500 years ago, more or less by accident. And what we set out to do in the Galapagos is to see if there was any earlier human occupation on the islands, and also can we reconstruct this World Heritage area's history by looking at sediments. So if I can have the next slide. So this is the group of islands in the Galapagos, and the main population is on the central island of Isla Santa Cruz and on Isla San Cristobal on the eastern side, on the right-hand side of the slide. So we focused some of our research on Santiago Island, which is in the middle, and you can see there's some black dots where we have archaeological sites and paleoecological sites where we reconstructed the history of that island. Now, Santiago is very interesting because it doesn't have a population. It never had a population. It only had a very small settlement hundreds of years ago of pirates that were there temporarily. So the next slide. So the use of Google Earth, it was very important to us because it gives us an eagle-eye view of the environment. So this is the western side of Santiago Island. And as you can see, the dark spot is actually very young volcanic activity. It's a lava field. And to the left of that, you can see a crater with a crater lake. Now we're going to focus in on the little beach just to the east, to the right of that lava field. And so the next slide. So we can see the little beach, and the green triangle in the middle is a lake with very eutrophic, rich water. And the white bit on the right is a lagoon that's completely silted up. So there's no water in it at present. It might be inundated by the sea periodically in storms, but it's full of sediments and it has a salt crust on it. And you can also see on the left-hand side, bottom of the picture, there's a little stream that goes into the lake that is completely sealed up, the white salt plain. The bright green colors around those lakes are actually mangroves. So both of these lakes are near sea level, and the only vegetation that grows there is mangroves. So next slide. So this is focusing in again, and you can see the big difference between those lakes. So the green lake has an extremely small catchment. The whole catchment can be seen on this photograph. The one on the right with the salt plain and the creek flowing into it has a huge catchment, probably going up to the highlands of this island, which is hundreds of meters above sea level. And for us, that was a very interesting lake to study. We studied both, but they had completely different signals when it comes to human impact on the ecosystem. So next slide. So this is us standing on the lake bed, and you can see we have on the left-hand side we have a sediment sampler in the sediments, and in the middle we are actually looking at the sediments that came out of the lake. We recovered about 6-7 meters of sediment from this lake, and it contained, after many years of study, we found out that 6-7 meters also contained about 6,000 to 7,000 years of environmental history from this island. Now in the background you can see the mangrove forest, and then behind that you can see the natural vegetation of the island, which is tree dominated with lots of herbs and grasses in the undergrowth. Now, something about the Galapagos is that it has a very variable climate. It's very sensitive to what we call the ENSO signal, the El Nino and La Nina cycles in the weather. At the moment in Australia, especially on the East Coast in Sydney, we are still having a La Nina phase, which means extremely high rainfall over the last 2 years. And that also means that in the Eastern Pacific, in the Galapagos, and as we can see in California at the moment in the USA, they have very much dry conditions, which leads in California's way to lots of bushfires and forest fires that actually are very bad for the environment and the people who live there. So Galapagos is right on the equator, so they are actually at the brunt of these cycles. So any changes we make to the climate system and to the El Nino, La Nina cycle to make it more intensive will have an effect on these ecosystems on the Galapagos Islands. So the next slide. So this is a view from the hill in between the Green Lake and the Sealed Up Lake. You can see just behind the little tree in the middle there, the beach ridge is a little bit higher than the lake itself, and the beach ridge is actually full of turtle nests. So it is a very interesting environment because there are no humans on the island. The turtles can nest in peace, and we actually saw the eggs coming out and the little turtles, the sea turtles going into the sea. So next slide. So again, this is a shot right on the lake floor, and you can see the hill in the background where I just stood looking back, and behind that lake, behind that hill is the Green Lake. So next slide. So this is the vegetation in the highlands, and you can probably not see it, but there is a little pole right in the middle of the photo, like there's a little pole with a little sampler at the top. We left those there for 1 year, and during that year, it collected the pollen from all the plants that are currently flowering on the island. So we get a little bit of an idea which plants produce most pollen, which we actually can find in the lake bed and in the fossil record. So we have a modern equivalent of the island's vegetation and the pollen record, and then we compare that with what we find in the sediment cores from that lake. So next slide. The lake is also a bit of a graveyard for the sea turtles. This is where the old ones come to die, and then of course they get also preserved within the sediments. And these are really big turtles. They are not the tortoises that live on land, but these are the sea turtles that live in the sea. So next slide. Now this is an overview of one of the sediment cores, and we analyzed that for many we use a technique called X-ray fluorescence, and the X-rays beam at the sediment core, and then you get a signal. And from this signal, the chemical imprint, we can actually learn a lot. So on the extreme left, you can see an image of the sediment, which is not interesting per se. It's just a bit red-brown mud. But next to that, you can see an X-radiograph, so like having an X-ray in a hospital. And you can see there's lots of layers and thick black layers and light layers. And we now know that all these layers are a reflection of the La Nina and El Nino cycle. So in dry periods, which is in this part of the world is the La Nina, you get more salts in the lake because of high evaporation and low rainfall. And during the El Nino, with high rainfall, you get actually more runoff from the island itself, more organic matter, and also finer sediment, which actually is dark in this picture. Now, interesting to note is that the next graph is silica next to that X-radiograph, and it is present in the deeper core, but then it stops toward the top. And that's interesting to note, and that creates a change in the history of the lake itself. Something happened, and then a big change, and then silica is no longer present. Next slide. Now we see similar things happening with the three elements on the right-hand side of the same core. That is chromium, that is strontium, yttrium, and zirconium. They all seem to drop off towards the top. So the next slide. So the next slide actually is the same thing again, and then we actually found out that towards the top there is unprecedented change in the lake's history. And if we go to the next slide, you will actually see that that has a profound impact on the type of sediments that were deposited in this lake. Next slide. So the simplified sediments are on the left-hand side. So you can see that the top is dark red-brown clay. The chronology of the sediments are in the middle. That big line with the green dots, that is the nuclear dating techniques that we apply to this core. And then the black line, the wiggly line, is magnetic susceptibility. And we know that magnetic susceptibility doesn't have a signal in marine sediments, but it does have in terrestrial sediments. So you can see there is a big change from deeper in the core to a signal that is very high in magnetic susceptibility. And that we were a bit puzzled why that happened. So next slide.
Terima kasih.
Next slide. So we know that something drastic happened on this Santiago Island. Goats were introduced on the island to support the visiting pirates of meat. And this was not very successful in the beginning. So the goats didn't survive for very long in the 1800s. But in the 1900s, in the 20th century, they were reintroduced and they really took off. So the next slide. And it grew from a few hundred to tens of thousands of goats. And the next slide will show you what it does to the environment. Next slide. So this is an experiment that they did on the vegetation. So on the left photo, you can see there is a fence around the vegetation. And of course, within the fence, there's no goats. And on the outside the fence, there's goats. And you can see the vegetation is completely stripped by the goats because they eat everything. So, and they are really difficult to eradicate, especially in a remote place like Santiago Island. And on the right-hand side, you can see the same spot after the goats have been removed. Next slide. So this is what they've done to get rid of the goats on this island. It was a multi-year project which lasted for 5 years. So hunters went out on ground hunting in early 2001, followed by aerial hunting. So they shoot goats by helicopter. And then because the population really decreases very quickly by doing that, the last ones are really difficult to find, but you really want to have a complete solution to this. So they put a Judas goat in. That's a goat with a tracker around its neck, and they will find the other goats. And then it's really easy to find for the helicopter or for the hunters to find the last ones. And in the end, in 2006, there was confirmation that they really eradicated the goats from this island. And next slide. And we know that goats are really a pest to the environment by the next slide, because not only is the grasses sensitive to goat stripping the vegetation, but also trees. So the next slide. You can see goats are really good in climbing trees. I never expected that. These are photos actually not from the Galapagos, but from Morocco. And these goats are very handy in climbing trees. So you wouldn't think that animals with small hoofs and 4 legs can actually climb trees and eat them completely bare. So getting back to the sediment record. Next slide. We now know that this dark red-brown clay in the sediment record, the top 130 centimeters, was deposited extremely quick during the 1950s, during very intense El Nino. The goats had eaten all the vegetation. The soil was very susceptible to erosion, and combined with intense El Nino, high rainfall, that 1.5 meters deposited in the lagoon and filled it completely up with sediment within 1 decade. And of course, this is a bit of a disaster for that lake and for the island itself. But with careful managing what it can do, because the soil on the island actually produces the vegetation. So without the soil, vegetation is very difficult to re-establish. So getting rid of the goats is one thing, but to re-establish soils on the island will take much longer. So the last slide for this example. Next slide. So through time for this lake, we went through historical variability, where we know that the vegetation can deal with La Nina and El Nino cycles. But what we did was, where the question mark is, we introduced a goat to the environment, and the normal variability that the vegetation can deal with is actually pushed out of its comfort zone, and we go into a period of unprecedented change. Next slide. The interesting thing when we were doing the field work was that these Galapagos hawk, a bird of prey, was following us around because they got used to the earlier 5 years that hunters would go out and shoot goats, and that was free food for them. So these birds were thinking that we were hunters as well. So wherever we went on the island, we were followed by a group of hawks thinking that they would get a free feed. So next slide. So they look friendly, but they are a very dangerous thing to have in an environment that's not used to exotic pests like goats. Next slide. And the next slide. Okay, now the second example is going south to the Antarctic. This is a field work that I undertook in the 1990s. The environmental problem in the 1990s was a little bit different from the current problems, but one follows the other. So the science was, we were going to sample fossil algae in coastal lagoons in the Antarctic. And this is a project with the University of Tasmania. And the question was, do algae suffer from increased ultraviolet radiation because of the hole in the ozone layer? Now, the hole in the ozone layer was caused by gases that were released from refrigeration. And these are actually destroying the ozone. And the ozone layer in the upper atmosphere protects us from very dangerous ultraviolet radiation. So the hole was discovered by satellites in the late 70s, and we saw it growing to a massive hole that also affected Australia. And it wasn't until the late 1980s that the Montreal Protocol was signed under the auspices of the United Nations that these gases were no longer used. Alternative gases were found for refrigeration, which are not destructive to the ozone layer. But meanwhile, this fragile ecosystem, this coastal ecosystem, which I'll get into a little bit more detail in a second, was potentially a threat to this ecosystem. So next slide. Now, first you have to get there. It's a very remote area. In the background, the big orange ship is the icebreaker. It took us about 3 to 4 weeks to get to the Antarctic with all our equipment. Next slide. And you won't see your family in that case for 3.5 to 4 months. So I was away on field work for 4 months. So next slide. Of course, this is the bridge of the ship of the Aurora Australis, and it's a really good vantage point to look at the environment. Next slide. If you don't like, if you get seasick, I wouldn't recommend this trip because it's a very rough sea in the Southern Ocean. Next slide. But once you go further south, it starts snowing and it gets extremely cold. So next slide. And the temperature drops to -15. And it's only that you are relieved from seasickness when you hit the ice. Next slide. And this is what we call pancake ice. And that actually means that you are no longer getting seasick because the waves are tempered by the ice. So next slide. So this is our training because it's a very dangerous environment to work in. So you have to have a lot of training in rope work in case you slip into a crack in the ice. Next slide. This is the icebreaker from the air. So it has a helicopter deck with 2 helicopters for transport of people and materials. Next slide. This is the wildlife on the way. So penguins, the penguins you have to bear in mind because that's what I'm going to talk about in a minute, because they are actually most critically in the food chain, which I'm going to talk about with that UV radiation. Next slide. There was lots of different scientists on board, and also people that actually maintained the stations for Australia in the Antarctic. So there was plumbers and carpenters and builders and cooks and doctors on board to help us with our fieldwork. Next slide. And the next slide. So this was my home for the next 3 months in Antarctica itself. So the colored boxes are all different buildings of the Davies station. They have different buildings because in case of a fire, only one building burns down and not all of them at the same time. And it's a very remote area. So we had one living quarters, and then the science building was different. All right, so getting back to the science of algae, the next slide. So why is this science of algae important? As you can see on the top left-hand side, what happens every year in winter, the sea ice, the sea freezes around Antarctica. It grows in size almost by 75%. The sea ice is about 2 meters thick. And in spring, when the sun comes back, because the summer is pitch dark, the winter is pitch dark. And in spring, when the sun comes back, the sun penetrates through the sea ice and algae start growing at the bottom of the sea ice. So that's that green blob at the bottom of the ice. Now you get an algal bloom in spring, and in what it looks like is the photo at the top. So you can see that brown-green layer within the ice is the sea ice algae that is a result of the coming back of the sun in spring, so they start photosynthesizing again. Now this algae is extremely important in the food chain, because the photo below that is actually a little shrimp that is feeding on, or krill, it's feeding on that sea ice algae. And that krill is of course the main food source for most of the birds and the mammals in Antarctica. So all the penguins and the seals and the whales, they all eat that krill. So the theory was in the late 80s that hole in the ozone layer and the increases in UVB radiation would actually be detrimental, if not kill off that sea ice algae in spring. So that would mean that the main portion by mass of the food chain would be knocked out. And we wanted to know if that was true or not. And by studying fossil algae from the sediments at below the sea ice. Because what happens in spring is the sea ice algae, after that bloom in spring, they run out of nutrients and they die, and the fossilized bits actually accumulate at the bottom of the sea. So we took a lot of cores, and we looked at the fossil algae to see if the ecosystem had the same composition, and also with the sedimentation rate to see if the production of these sea ice algae has changed over the last 100 years before the hole on the ozone layer. Next slide. Okay, so that's the picture of the hole on the ozone layer at around that time. And then the next slide. Being the applied physicist that I became, we provided for these sediment cores. So the gentleman is standing next to a sediment core. All that brown stuff is actually 1.5 meters of sediment from this coastal lagoon. It was sampled at about 100 meters water depth. And we looked at the natural occurring radiation of the isotope lead-210. It's got a half-life of 22 years, and the highest activity of that isotope was found near the top, and then with depth it decreases, and then you can calculate an age for each of the layers. Next slide. And what we found was what we expected, or what a lot of the biologists were expecting, that you can see in the background there. We expected historical variability, again, with different years of different intensity of the winter, you would have more or less sea ice and more production of the sea ice algae. And then because of the hole on the ozone layer, we have unprecedented change which knocks it out and might actually knock out that fragile ecosystem. But what we found is that it had minimal effect on the Antarctic diatoms over the past 20 years of the history of the hole in the ozone layer, because we could compare it to much earlier layers of the 19th and 20th century. And this was big news at the time. And of course, with the Montreal Protocol, that hole on the ozone layer started repairing itself in a natural fashion ever since. But of course, we introduced a new problem, which is global warming. Now, global warming has an effect on the, not directly on the diatoms again, but on the extent of the sea ice. So the extent of the sea ice, if it's 30 kilometers from the coast or 120 kilometers of the coast, by mass of sea ice algae, that is a big difference. So the study since the 1990s has changed to see what the global warming is actually doing on this fragile ecosystem. And that's a whole new generation of researchers that build on our knowledge of reconstructing these environments from sediments over the last 100 years to learn from the past. Because in the past, there was also natural global warming. So even in the past, we can actually see periods where it was warmer, less sea ice, and what did that do to the fossil, to the algal community that was growing on this sea ice. And so if you are in a scientific career, you might find yourself solving one part of the puzzle or solving the whole puzzle, and then all of a sudden you find yourself that there is a new puzzle to be solved. So I am happy that the whole new generation, especially in Australia, and I hope also here at Undip, by supervising students, that they will be ready to tackle the new problems of climate change, environmental change, and water resources stress, and like me, that I can present in about 30 to 40 years and said, well, I was part of providing solutions to these problems that occurred during my early career. And now in my late career, I can actually look back and I contributed to making this a better world. And I would thank you for your attention. Terima kasih.
Yeah, thank you very much, Prof. Hanks, for the presentations, and it's also a more valuable session for this today. Come to the next presenters. I invite Dr. Reddy, and I also will read his CV shortly. So Dr. Reddy obtained his PhD in 2003 in the area of material sciences and engineering from University of Bordeaux, France. From July 2003 to 2019, he worked at Department of Material Science and Engineering, Chemistry of Physics, National University of Singapore. And from June 2019 to August 2021, he worked at the Center of Excellence in Transportation, Electrification, and Energy Storage, Hydro-Quebec, Canada, and currently working as senior professional researcher and group leader in energy storage technology at Nouveau Monde Graphite, Quebec, Montreal, Canada. Dr. Reddy has published more than 200 papers in various international journals, and he has high index of 69 with 17,600 citations. And he also serving as editorial advisory board, member of Material Research Bulletin and Journal of Energy Storage. This is a journal belongs to Elsevier, Scopus Index Journal, and also as well as several open access journal. He got also some awards, Outstanding Science Mentorship Award, Inspiring Research Mentors Award, 2021 Battery Material Electrochemistry Award from the Electrochemical Society of India, and others award. Okay, Dr. Reddy, the time is yours.
Okay, thank you, Chairman, for your kind words. So my voice is audible, sir? Is okay?
Yeah, it's okay.
Okay, thank you very much. Thank you. Okay, once again, thanks for the organizer, Professor Budi and all his team for organizing this excellent international conference. In fact, my previous speaker talked about the importance of biology and environment. In fact, so I'm going to cover then what are the importance of materials, mainly in energy storage and environment and something related to the sustainability. Since this conference is a wider audience, starting from science and engineering, both basic sciences and engineering, so I'll try to make it as a balance my slides such a way that, okay, some slides may be useful and also some slides may be interesting to some electrical engineers. Some people are interested to some science and engineering graduate students. So presently based in Quebec, so what this is a place where they both French and English speaking colony. And also we can see again, you see that in addition to the differences in extreme low temperature, also sometimes we can see the -30 also in few days in a year. Again you can see beautiful, especially here. I think this is very entirely different season when compared to the Indonesia. So this outline of my presentation. So without since many young students are there, what I'm telling you that research is no boundary. In fact, these are the few examples I've been trying with a lot of young minds in the area of energy and environment and health and environmental research. So it clearly shows that some of the output we published with the various international journals, some ACS and Scopus journals, and a few students presented like me, and they are able to present in the various held in Singapore, as well as few other places held in USA and Europe and Japan, etc. So also I think I had we have a long collaboration. In fact, some few publications with Indonesian universities with the various, starting from ITB and few University of Indonesia and Manado and a few other places, for including that Patimura, etc. In fact, I visited many places during when I was worked at National University of Singapore. So that I think the nice opportunity and talk with the young minds at Indonesia. I think many smart students. I think that is a nice, especially. So I'm not able to visit your university in future. I'll try to visit your university in future. And these are the small group with both Singapore as well as few other part of the world. The PhD students have been trained. So these are my small collaboration. It clearly shows that Indonesia, we have been already few places in the ITB and Padijara and few other universities in Indonesia. And also we published some joint papers and also some joint collaborative students, etc. We've been done. I think this is very important since we are an academic or anything collaboration or international exchange. I think that is very important. That's why you people are doing very great job. Maybe inviting some of our Australian speaker. I think that is very good. Exchanging the ideas, etc. So these are my research interest. Maybe today I'm focusing on the importance of lithium batteries. I think those are all people are familiar. These batteries are using your electric vehicles. I think presently we know that we are facing that the environmental, for example, these are all the, especially batteries are one of the important, especially storage devices. We can reduce the global warming, etc. So again, the materials they were known from the very long age, starting from Stone Age, copper, iron, and rubber, especially Silicon Age. It has changed a lot. In fact, discovery vacuum tubes, computers, so on. You can see the miniaturization of your laptop, especially iPhones, etc. Again, the materials, silicon age made them to think in a different way. I think that is very useful. If you talk about mechanical engineer, composite materials also play an important role. In the year 1980, there is huge interest in this particular thing. And functional materials is called nanotechnology. There's huge interest in this one, either nanotechnology related to energy, both the chemistry, physics, and engineering and biology also. Now we call as a molecular age, year 2020, the future always people are talking about the intelligent and low carbon age material. Always you to reduce the CO2 emission. That is very, very, very important. Again, recent years, materials play an important role in the area of energy, environment, and healthcare and water technology. I think these are one of the hot topics by worldwide researchers. That's why you can see that everywhere. I think these are the very top important. Again, for this one, the materials will play an important role based on the utility. For example, building and construction. I guess again, the technology very depending on the, for example, place like India or Asian countries. It will vary depending on the Canada or some other cold countries again. And electronic material, I think all people are familiar with silicon, germanium. These are used in solid state electronics, explosive material, engineered material. For example, people are talking about superalloys. I think these are all the materials will play an important role in the, for example, construction and other few other applications. In the foods and pharmaceutical industry, based on physical properties, metal, semiconductor, insulators, magnetic materials, optical materials, dielectric, and radioactive. Again, I think today I'm going to discuss the importance of energy storage material for electric vehicles. Either you can use the same type of devices, you can buy smart grid and portable electronics, etc. Other important area, the CO2 capture sometimes is very difficult to 100% stop the CO2 emission. Another way is to capture the CO2. Again, the materials will play an important role in the capture the CO2, etc. So these are one example. You can see that where the Canada, you can see the construction technology will vary because here extreme low temperature. So sometimes it has to withstand. That's why either a wood or also in between there is an insulation layer in the construction industry. And another important importance of the steel and then again and composite materials that are useful in the construction industry and transportation, etc. Again, you can see that, for example, carbon-based carbon fibers are used in the aerospace industry. So another important, if you are a physicist, especially glass industry, the optical materials, again, there is a lot of the electrochromics or sometimes lasers or glass fiber. Again, the materials play an important role in the area of the especially electrochromic industry or what they call as optics. That's why there are a lot of interesting physics also we can do this one. And especially silicon based PV solar technology, again, there is a lot of interest in the especially this one, the silicon and a few other type of the materials. Again, I think sometimes people are talking about the air thermoelectric materials. For example, you see that cooling the our especially fridge, and again the materials play an important role. So these are the important materials. Again, if you're talking about the civil engineering in terms of the building, people are looking for the thermal insulation, heating and cooling. And sometimes people are talking about 3D printing materials, energy saving lights, robots, motor, again the smart glass, etc. Another important area people are looking at the smart photoelectronic means organic electronic means we need a photo because presently silicon technology is a little bit expensive. Suppose if you use any polymer based systems, we can roll to roll, we can do using inkjet printing, we can get a large scale solar cell. That's why we need to look for organic important flexible organic material. Another is resistive system memory applications. Again, especially thin films will play an important role here, especially here. And sensor for lidar technology, especially if you talk about the autonomous electric vehicles, we need a smart sensor again. So, and also again the 2D, 3D material for graphene. And again, for example, presently everybody accessing the internet. We want this fast internet. That's especially due to COVID. There is a lot of huge rise in especially a lot of people are working from home, or many students accessing the internet from the home. That's why especially all the teaching various course mode. Again, the people are looking for the 5G, 6G terahertz electronics, and we need a smart material, smart grid, and electric vehicles. Again, and the smart charger. For example, if you're talking about the electrical engineers or power electronics, I think they are very interested in the developing the smart chargers or wireless chargers, etc. With a different type of the thing, and advanced material for CO2 capture and storage. These are all the according now presently. If you talk about information science, I think again this play an important role. Without doing experiment nowadays, we can do multi-scale modeling of the predicting new materials and AI automation and what are the image processing, etc. Or especially if you talk about in industry, people can automate the things. I think that's especially information science also is playing important. That's why this conference is one of the conference people have been talked about the different variety of the topics that both science and engineering. Again, the materials, if we talk about the various applications, starting from the energy, environment, and photonics, aerospace, and healthcare industry. Again, if you talk about presently to solve the green environmental problem, we need a green renewable technology. For example, solar, especially places like in Asian countries, we have a huge amount of solar energy. And places like in Quebec, where Canada, there is a lot of water. That's why electricity generated mainly on hydroelectricity, and few other things, for example, wind, mechanical, nuclear, and geothermal, etc. If you talk about batteries, batteries are one of the for example, these are the very important devices. For example, if you see any major cities, 50% of the pollution is coming from the four-wheelers, for example, cars. That's why, and also rise of the crude oil prices. I think people are looking for the alternative, for example, replace the gasoline vehicles with battery operated electric vehicles. In general, energy and environmental engineering is interdisciplinary. I think we have to understand the material engineering, mechanical engineering, automobile, and chemical, information engineering, civil, etc. And also you can see the basic and sciences. For example, we need the importance of physicist, chemist. I think there are also some cases nowadays recently very good in mathematics also, because sometimes modeling or solving the equations, I think mathematics and statisticians, and at the end we have to work with some, in case, for example, as an industry perspective, we have to work with our lawyers also, because they are the people discussing environmental issue, for example. So I think that is very important, all environmental engineers. That's why it is a multidisciplinary area of things. Again, the importance of energy storage, as you can see clearly, if you want to store the solar or wind or run with electric vehicles, or if you talk about the smart grid or smart housing, the batteries play an important role. And idea is that again, they to solve the environmental requirements, for example, to reduce the CO2, SO2, acid rain. I think it is very, and always we use a green and renewable technology. Again, another important price, you can see that maybe last three to 4 years, there is a huge rise in the almost double the price of the petrol price. That's why the people are looking for the alternative energy. The main issue is that, for example, you talk about smart grid and plug-in electric vehicles, we need a kilowatt to megawatt, means that we need a large scale material. For example, so we have to recover, I think we have to produce the material in a locally, for example, places like Indonesia, we have a lot of interesting mining. For example, like nickel is one of the main interesting ore that can be used for the battery electric vehicles. The main issue is that any country, we have to produce the raw materials locally and fabricate. I think that is very important too, because the car batteries, we have to raw materials coming from one country to transport to another country. That's why the transportation cost also is rising. And again, you're making some other environmental issues. Again, if we talk about the CO2 emissions, again, I think all people are familiar what is the adverse effect of CO2 emission. We can see the if we keep on rising, automatically we can see the variation of temperature. Keep on temperature is rising all over the world, and not only including the Asia, or including especially so in Quebec or in Europe. All the, when compared to the olden 50 years, there's huge the rise in the, for example, there is a small increase of temperature also, that is mainly due to the global warming. So again, I think these are the different type of sources, and people are talking about, for example, coal mine and also gas plant, and for example, you talk about the photovoltaic, you can see that almost like zero CO2. Again, I don't think it's not really true. For example, in order to produce the silicon solar chips, again, you have to emit some CO2 gases. So another important area, if you are electrical engineers or any, so if you talk about autonomous electric vehicles, there is the lidar and computer system, and there we have the battery engine, and also we need some way to work with the engineers. For example, if you have the mechanical engineers and all, including all different type of engineers, you have to work together to solve these particular things. That's why it is interdisciplinary, especially students, for the graduate students, is a nice opportunity for us to especially can work in interdisciplinary research and at least try to understand what are the real issues, especially in terms of academic and applied interest. I think these are the different type of the companies are investing. There is a lot of future in this, especially in the transportation sectors. I think now briefly a little bit go through it. In fact, almost I finished 15 minutes. So I'm going to explain what are the important components. In fact, we have something like this type of power cell. So use it in your mobile phones, your laptops, you're using some cylindrical cells, and future run with electric vehicles. They put in different type of stacks, this type of big cells and the modules, and finally put it in the electric vehicle or pack. Always remember, so the main issue here is that when you put it in this type of big stacks, and make sure that you have to think about thermal management and also other issues, like for example, what they call as a thermal runway, and sometimes some particular batteries are catching fire. That's why there is a lot of interesting thing about sensor technology. That's why we all, the electrical engineers and mechanical or material engineers, we have to work together to solve this particular problems. I think people are familiar. 2019 Nobel Prize has given with battery research. In fact, this year, Professor John Goodenough turned 100 years of his birthday, and also we are grateful that we have been presented some of our work with this 100 years birthday. It has recently happened in the last month. It was a really great honor for Professor John Goodenough. In addition to other well-known laureates, I think all other 4 people also play an important role in the development of the battery. So what are the important components to remember? There is a cathode, anode, and there is separator and electrolyte we are using. What it will do is that electrolyte is a medium transferred from lithium ion to cathode to anode or onto cathodes. Okay. Usually cathodes, we use some lithium containing inorganic oxides. If you talk about lithium, you really replace by sodium or potassium. But now most commonly the lithium batteries are more popular because of the good energy density and voltage and capacity. So negative wise, the most commonly presently graphite is well known because of the naturally occurring source. Graphite or artificially also you can get. And also we can use lithium. The problem is the safety issues, most commonly the graphite. Or if you replace by lithium soda, there are different type of sources, or if you want to use some silicon to improve the capacity. Some metal oxides are similarly, if you talk about calcium, aluminum. The main issue is that if you go for higher ionic radius, we have some issues related to the, for example, stability and the capacity. And I am going to use something like charge, oxidation, analytic scan, SOC, discharge reduction, and we use some inorganic electrolyte and polymer sometimes depending on the battery pack, and sometimes binder and copper, and especially anode side copper, cathode side is the aluminum current collector we are going to use. So this is a typical principle of lithium batteries. It is nothing but shuttling of lithium between the cathode to anode, whereas the electron will pass to the external circuit. During discharge, again, lithium is going to back to the battery. That's why we call it the rechargeable batteries. So it is typically when you remove the lithium, voltage will develop, means oxidation, reduction. Similarly, the voltage versus capacity, it means that the charge when it discharge, we can see for example, voltage difference. That voltage difference multiplied by capacity will give the energy density of the particular battery. Always it is very important. If you would like to consider any good new materials for the batteries, we have to see the higher difference in charge and discharge voltages, and we have to get higher capacity. So this is a very important point you to remember. Always you to look for high energy density and power density. Adapt the climate condition, means it is to work with the low temperature and high temperature, long cycle life and more reliability, and working voltage, good Coulombic efficiency, and low impedance is nothing but resistance should be minimal, low, and fast charging. People are all looking for, is there any possibility to charge the batteries within few seconds or 1 minute is a thing. After doing all this one, we need a more safer material, low cost and low toxicity and sustainability. I think this is very important. In fact, this conference is going to cover about the any area, whatever the research we do, it should be sustainable and recycling. I think that is very important. We have to consider for, especially for the future generation. It is not like we have to generate the waste, you have to recycle them. That is very important for our like future, especially sustainability and environment, etc. So in summary, why lithium batteries are very popular? Because of lightweight and the smaller high volumetric energy density, and that can use it for the various applications, including space and etc. So now I think one quick slide, I'm telling that what are the typical mining process. For example, any mining, I think we need some minerals. For example, for lithium battery, they're very important: lithium, nickel, manganese, cobalt, and these are the important minerals needed for the electrolyte and cathode fabrications. And followed by graphite as another, and aluminum, stainless steel, and polymers. Neodymium, dysprosium, these are needed for permanent magnet. Another important factor is the silicon, because silicon fab, because if you see the any displays, we need a silicon-based system. That's why we need a fourth one. Afterwards, component processing, cell pack, and cell manufacturing. This is very important. Sometimes once you assemble cell and end use, either you can use EVs or smart grid and power, and end life and recycling. So usually people may ask you why the cost of the final product is relatively again depending on the yield. For example, 30 tons of the mineral of cobalt will give 30 kilograms of cobalt, whereas the 5 tons of the mineral nickel gives 60 kilograms of nickel. It clearly shows that nickel is, that's why nickel-rich cathodes are playing an important role for the EV. So if especially place like Indonesia, I think you people have a lot of good, for example, number one rich in the nickel resource with Indonesia. That's why there is a lot of opportunities future. I think a lot of good company battery they're going to install, especially in Indonesia. Why? Because we have a lot of interesting, and also copper and few other minerals. Also, you have a lot of good in the, especially in terms of mining perspective. So these are typical battery now presently dominate in China, US, and Europe, and then Japan, Korea, etc. That's why future, for example, we talk about electric vehicles again. Instead of sustainability or long-term things, locally is to produce, fabricate everything, then only so we can use it for in terms of law, because since we have used sometimes millions of tons of the materials to prepare. So that's why we need a locally, we have to, especially in terms of mining and metallurgy and engineering, is to, especially you have to train the engineering graduate students, especially in this particular area. So especially if we talk about graphite, again, the same materials at the industry point of view, we can different type of sources. For example, place like our presently in new graphite world, we are producing different type of graphite with the various applications. Although interest is in electric vehicles, again, still depending on the waste product or depending on the size and shapes, again, people can use it for the various applications. As you can see, there is a lot of opportunities and lab, especially carbon-based materials for the various applications. So now quickly I'll go to, since my time is up, maybe another 5 to 6 minutes. Material manufacturing usual way is that depending on application properties, and again I have to do process them, characterize them well, and that is very important. And nowadays, if you based on nanotechnology or processing, we can do various type of shapes, and it's possible. And also, especially with the different type of processing techniques are possible, either, for example, bulk materials or thin films. We want the solar cells, we need a thin films. Or for example, even metallurgist, you are working with something like hard pressing, additive manufacturing is needed for, especially some few material processing people are producing a large scale. And especially for thin films, we need a, for example, metaplasmonic applications, we need a different type of the things. Again, these are the two time limitations I'm going to stick with. Either you can buy chemical vapor deposition techniques or physical vapor deposition techniques. Again, I think these are always depending on application, thickness, and composition, everything you have to optimize them. So I think this characterization techniques is very important. In fact, our previous speaker has already talked about importance of physicists. In fact, I also had a nice opportunity. So I work with a neutron Ansto with some of the, since we work the lithium based materials for the, since lithium containing materials easier for us to do with the structural analysis with neutron diffraction. So that's why we work with Ansto Australia, and especially with the lab scale XRD with the materials, we can characterize them, phase purity, etc. and exorbs, etc. And for example, with the nuclear reaction techniques, or for example, if you want to use it for various applications, for example, density, or sometimes like ADAX means energy chemical analysis is very important. For example, previous speaker are talking about the for environmental material analysis or anything, we need something like, for example, titration techniques, etc. So quickly we'll go through some few example for the cathodes and anodes, and especially these are the promising materials are used in the electric vehicle or market. For example, NMC, LFE, and a few graphite as anodes. So they're going to use. So the main issue is that people why to talk about the fast charging. That's why if we do with higher current rate or fast charging capacity, we may not get. That's why if you use any battery chargers or if buy any vehicle, I think sometimes you have to wait for minimum 1 hour or something slight, so that or sometimes depending on the battery technology, people they can fix the what they call a BMS, etc. So these are the, if you talk about industry, always people are picking in kilowatt range. I think all are automated. It only need a something like millions of the huge investment is needed to produce the gigawatt battery pack. And advantage here is that we can fabricate everything. Is automation is also possible. So these are the typically as any R&D or any laboratory you can do in a small scale. Once you your material is promising, then you can standardize them in large scale. Also is possible. This is a way typically coating and take into cells and can put in this one. So with the typical kind cells, it looks like this way. For example, you can make a button cell, or you can test how long your batteries are going to last. For example, capacitive or cycle number. And also important point to remember, you to see the voltage, higher the voltage and higher the capacity. That is very important to design the energy density of this one. Another lot of interesting people may ask why the sodium batteries. The main issue is the sodium batteries lower voltage as a consequence. Although cost will be lower, again lower energy density. Again, you have to think about depending on which type of applications. Again, as a, for example, if this type of materials for processing, for example, people are biology or nanofiber technology, people are using for the skin and biomedicine, medicine, medical. Again, the importance of the fabrication, what you learn from the bioengineering, we can use it for the various applications. Also, materials play an important role in their example. TiO2, we can. This is also one of the important mineral we're getting from Indonesia. In TiO2, SNO2, there are semiconducting materials, and we can use it for various environmental applications, electrochromic, solar cell, batteries, protocol, paint, and also few other applications. Again, these are the importance of the materials. Another important, for example, some semiconducting materials, people are using it for the, in terms of the, for example, sensing applications. I think this is very important. For example, you see the automobile exhaust, I think materials play an important role. For example, alumina or zirconium doped materials are people are using. For example, the materials are using for the automobile exhaust sensors, etc. So, and also some, for example, fast charging, although we can get some supercapacitors, also we use it for the, for example, in carbon with we can do it interesting supercapacitor. So another 2 to 3 minutes, I'll go through what are the importance of thermal runaway. I think sometimes my batteries are catching fire. They mainly due to the very complex, either due to the cathode, electrolyte, and then anode, and then that's why sometimes it is importance of engineering, either due to the cathode side, overcharging is not good. Sometimes it may lead to thermal runaway, and also it leads to temperature spike, etc. Especially electrolyte, with oxygen will release at the end, so thermal runaway. And separator mechanism sometimes may give to functioning the separator, also we can lead to the thermal runaway. Similarly, for the anode side, also we have to remember we cannot do with the fast charging. Sometimes the current and also current collector also. This in summary, that's why we get to the intrinsic safety. That's why we have to work with both the engineering side with mechanical, electrical, and a few different type of engineers to work to solve this particular problems. I think quickly I'll tell the importance of sustainability. Whatever we research you do to recycle them. The main issue is there's so much of nearly 11 million metric tons spent batteries in discovered 2030. It means that any raw material we cannot dispose, we have to recycle them. Again, if you don't leave it, it leads to global warming, etc. So always what my take-home message is that I'll be able to educate them to recycle them. We cannot throw the materials. Again, technology is known only matter of the yield, and then, for example, recycling cost. That's why while buying the battery pack, the cost of the recycling is being included. As a consequence, you have to. These are the typical cycling process. Again, the recycling, that's one I can do. Anyway, each technology, especially parametallurgy, already been demonstrated with the various industry within Europe and few other part of the world. And each technology will advantage, disadvantage. For example, you can see raw material, what you are putting, then we cannot get the same thing. You have to recover them 2 to 3 different ways. Again, the cost of the processing is also increasing. I think these are my small conclusions. So there is a nice scope for the mining and manufacturing, zero emission, and also basic knowledge and experimental training in industrial and mechanical both are needed for the young students. Again, the future, for example, in terms of the cooperation of scientists and engineers needed for the large scale application. I think I'm going to stop now. So later, maybe I'll take some question and answer. Okay. Thank you very much. Okay.
Yeah.
Jamakase.
Yeah. Thank you very much, Dr. Reddy, for the presentations regarding the application of materials, not only for environmental, but also for energy. And I see also application in health sciences. Okay, we jump to the last presenters that will be doing by video online presentations. Maybe the committee can start the video. Before the video is on, I would like to read the curriculum vitae of Remco Harman van Merms. He is now a species conservation grant coordinator from International Union for Conservation of Nature of IUCN. And he also had experience as head of species conservation action at Interim at IUCN as well, and World Heritage Conservation Officer at IUCN. And he graduated from Wageningen University, Netherlands, and also from University of Greenwich, United Kingdoms. The video is on. Okay.
Good morning, ladies and gentlemen. My name is Remco van Merm. During the pandemic, I managed a grant-making program for species conservation at the International Union for Conservation of Nature, or IUCN. I am also a member of IUCN's World Commission on Protected Areas. I will speak to you today about the impacts the COVID-19 pandemic has had and continues to have on biodiversity conservation, and the lessons we can learn as the world is aiming to build back better. But before I start, allow me to thank Undip for organizing this conference and for inviting me to speak. And I do apologize for not being able to join in person. But without further ado, let's dive right in. Early during the pandemic, when the world was in its first lockdown, there was a misperception that nature was getting a break from human disturbance. We have all seen the pictures of clear blue skies in usually heavily polluted cities, such as Delhi and Beijing. It's true that during the lockdown, these places experienced an improvement in air quality, but this was only temporary. During the first lockdown, the internet was also rife with stories of wildlife reclaiming urban habitats. There are examples of deer roaming streets of Nara in Japan, or macaques overrunning the city of Lopburi in Thailand, and even dolphins in the ports of Venice. Some of these stories, like the dolphins in Venice, have since been debunked. But what happened in Japan and Thailand was actually a symptom of a bigger issue with far-reaching consequences around the world. I'm talking, of course, about the collapse of the tourism industry. As tourists stayed away from Nara Park, the resident Sika deer were no longer being fed and ventured into the city in search of food. And the same thing happened to the monkeys in Lopburi. Around the world, otherwise crowded tourist destinations remain empty. The picture here shows famous Copacabana Beach in Rio de Janeiro before the pandemic and during the first lockdown. With the loss of visitors, these places also lost a significant portion of their revenue. In protected and conserved areas around the world, this continues to have major repercussions for biodiversity conservation. According to the World Tourism Organization of the United Nations, 7% of all tourism globally is related to wildlife. In many rural parts of Africa, where wildlife accounts for up to 80% of visits, local communities found themselves without a livelihood overnight. In order to survive, people were forced to rely more on the consumption of bushmeat. Poaching of valuable species such as the cushion-forming succulents of the genus Conophytum in South Africa became an attractive alternative income for some impoverished communities. And with the decreased presence of tourists and staff from tourism operators in protected areas, a major deterrent to would-be poachers was lost. The threat of poaching and other illegal activities, such as gold mining and logging, increased for many protected and conserved areas. While anti-poaching and law enforcement operations were allowed to continue through the various lockdowns, they now had to cover larger areas with fewer resources to face these increasing threats. In April 2020, ICEN Save Our Species, with generous funding from the European Commission, was one of the first organizations to provide emergency funding to conservation NGOs in sub-Saharan Africa in response to these challenges. Financial support of up to €100,000 for 12 months was provided to enhance anti-poaching operations, both through the use of technologies such as drones and surveillance cameras, and by putting more boots on the ground. As such, they also provided new jobs for local communities. At the same time, projects benefiting from an ICEN Save Our Species grant supported the development of alternative livelihoods and alternative sources of protein to reduce the appeal of poaching and the need for people to hunt and consume bushmeat. These projects offer examples of how local development and biodiversity conservation can go hand in hand, and this works both in times of crisis and in normal times. But while these projects made a big difference locally to the organizations and communities who benefited from them, they were only a drop in the ocean in the face of global COVID-19 impacts on biodiversity. As humanity is trying to recover from the pandemic, which is by no means over yet, governments around the world are talking about building back better. The development and implementation of economic stimulus measures and recovery plans should incorporate as a priority measures that help safeguard and restore biodiversity. But why is it so important then to conserve biodiversity? First off, it's important to understand that ecosystems function similarly to the human body. If your body is in good condition and well taken care of, you're less likely to fall ill. Similarly, an ecosystem that is undisturbed is less likely to be the source of disease. But as human activities encroach further on natural habitats, we come into contact with wildlife and pathogens that have so far existed in isolated areas. Human activities like logging, wildlife trade, and intensification of agriculture can also alter the dynamics of infectious diseases by changing species composition, the structure of ecosystems, and the ecological processes that normally keep diseases in check. Take agriculture, for example. With the expansion of monocultures, that is, fields planted with a single crop, the genetic diversity of crops erodes. Monoculture crops are more susceptible to pests and diseases, which is why they need to be sprayed with pesticides and herbicides. Similarly, intensive livestock production relies heavily on the application of antibiotics to keep livestock healthy in cramped production pens. The excessive use of pesticides and antibiotics is driving the evolution of pests and bacteria that are resistant to these chemicals, which in turn triggers the development of stronger, more aggressive poisons. This has direct consequences for human health, but also significantly impacts the functioning of natural ecosystems and their ability to keep diseases in check. When wildlife habitats are destroyed or degraded, animals are displaced and more likely to become stressed or sick, while also being more likely to come into contact with humans or livestock. Opportunistic or invasive alien species, which tend to be effective hosts for diseases, may take the place of the ecosystem's endemic species. In 2020, a study by Gibbs and colleagues found that in areas where human disturbance is high, such as agricultural and urban systems, there is a greater proportion of wildlife hosts of human pathogens than in nearby undisturbed ecosystems. COVID-19 is by no means the first epidemic transmitted to humans through different host animals. SARS and MERS both jumped from animals to humans, as did the Spanish flu in 1918 and the bubonic plague or Black Death that wiped out half the population of Europe in the Middle Ages. Other examples of so-called zoonotic diseases that are transmitted to humans by animals include Ebola, malaria, the Zika virus, and HIV. In fact, as this graphic shows, 60% of infectious diseases in humans are zoonotic in nature, while 3/4 of new or emerging infectious diseases are transmitted from animals to humans. It is not a matter of if, but when the next outbreak occurs, as the current monkeypox outbreak demonstrates. As human pressures on biodiversity continue to grow, the risks of another pandemic increase accordingly. Yet, as governments are making recovery plans and implementing stimulus packages to get their economies growing again, the need to conserve biodiversity is still very much overlooked. This is despite the fact that investing in biodiversity conservation will also benefit the economy in various ways. According to the International Monetary Fund, the cost of the pandemic to the global economy is projected to exceed $12.5 trillion through 2024. On the other hand, a study conducted during the pandemic by Dobson and colleagues estimates that an annual investment of $260 billion over 10 years on measures combating deforestation, improving management of wildlife trade, and improving disease surveillance in wild and domestic animals could help reduce the risk of another pandemic significantly. But pandemic prevention is not the only benefit we can derive from biodiversity. If we take a look at the Sustainable Development Goals as depicted in this graphic, we see that the achievement of economic and societal goals is not possible without achieving the biosphere-related goals. Humans rely on biodiversity for the provision of food, clean drinking water, raw materials such as timber, climate regulation and protection against severe weather events, and soil formation and nutrient cycling, among other things. In 2020, the World Economic Forum analyzed 163 industry sectors and their supply chains, and found that $44 trillion of global value added was moderately or highly dependent on nature and ecosystem services. This represents over half of the world's GDP. Given these dependencies, it makes sense for biodiversity conservation to be an integral part of countries' policies' responses to the pandemic. Yet stimulus packages that are potentially harmful to biodiversity appear to outweigh those that are beneficial. For example, some countries have loosened environmental regulations to stimulate economic activities that are likely to have a negative impact on biodiversity. Even if these measures are only temporary during the pandemic, they could reverse environmental gains that have taken decades to achieve. The world needs to make sure that the post-COVID-19 economic recovery does not compromise biodiversity. The OECD outlines a number of actions to guide policymakers in this regard. While they are all relevant, one in particular emphasizes the interconnectedness of human health, animal health, and the health of ecosystems. That is the adoption and strengthening of the One Health approach. The One Health Commission defines One Health as an integrated, unifying approach that aims to sustainably balance and optimize the health of people, animals, and ecosystems. It recognizes that the health of humans, domestic and wild animals, plants, and the wider environment, including ecosystems, are closely linked and interdependent. The approach mobilizes multiple sectors, disciplines, and communities at varying levels of society to work together to foster well-being and tackle threats to health and ecosystems, while also addressing the collective need for clean water, energy and air, safe and nutritious food, and taking action on climate change and contributing to sustainable development. We've already seen that 75% of emerging infectious diseases are zoonotic in nature, and that the risk of zoonoses increases as a result of human activities that disturb ecosystems and upset natural balances and processes. However, the emergence of diseases is not only about the relationship between humans and wild or domestic animals, but also about the complexity of the system as a whole, including the interactions between biotic and abiotic components. Biodiversity laws and the degradation of ecosystems compromises this complexity, making the system as a whole more vulnerable. When ecosystems have high biodiversity and the interactions in our landscapes and seascapes are more complex, ecosystems and the human societies they support become more resilient to disturbances such as the emergence of infectious diseases, climate change, and severe weather events. When industries recognize their dependence on biodiversity and the ecosystem services it provides, and implement measures to protect, conserve, and restore that biodiversity, they can contribute to achieving better health outcomes for humans, animals, and ecosystems. For example, as the world is opening up to travel and tourism is picking up again, the tourism industry should foster sustainability and carbon neutrality by increasing investment into protected and conserved areas and efforts to restore biodiversity and habitats. The agricultural sector, on the other hand, should farm with nature rather than fighting nature with pesticides. But this requires governments to reform subsidies that are harmful to biodiversity and instead provide incentives for organic farmers. Cross-sectoral collaboration is key to the implementation of the One Health approach. And Goal 17 of the Sustainable Development Goals is also about revitalizing the global partnership for sustainable development. As such, it is my hope that this conference, which involves a diversity of sectors, can help to make that happen. Thank you very much for your attention.
Thank you very much, Remco. Although it was done by using video, but we got all the messages for his presentations. Okay, ladies and gentlemen, we come to next part of this session is question and answer. I see all participants, or maybe not all, but some participants already give a question in the chat, and it's addressed to Prof. Alfonso and then Pak Heng and also Dr. Reddy. But probably some of you can have direct questions by raising your hands. I can give you about 10 minutes for direct questions, please, from participants, if you have any questions. Just raise your hands. No, if no questions, I would like to share all the questions from the chat box that I already copied to the Word file, so everybody can see. Okay. 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 The first question is addressed to Prof. Alfonso. Maybe Prof. Alfonso is still available. Prof. Alfonso, are you still there? Okay. Probably it's already left, but I see that all the questions actually already answered by Prof. Alfonso. Okay, to Prof. Heng, so you also have questions from Yuli Rutena. Questions is how to determine past climate change using sediment record. Okay, Heng, you can answer directly.
Okay, thank you, Yuli, for your question. So how do we determine past climate change from sediment records? Well, within the sediment record, there's all sorts of information. As I demonstrated in the talk about the Galapagos Islands, we actually look at the fossil pollen, and the pollen is a reflection of the vegetation of the island. Now, different climate conditions will lead to different vegetation on the island. So, for example, if the intensity of the dry phase of the La Nina and El Nino cycle prevails for decades or hundreds of years, which has happened in the past, then of course the whole ecosystem, the balance between trees and grasses will actually go more to grasses than trees. So what you find in the sediment is you find an abundance of grass pollen relative to tree pollen. Now that's only one example. In the lake itself, you have the algae, the diatoms. Diatoms are very sensitive to a lot of parameters. Water quality is one, but also water temperature. So depending on the climate conditions of the time, if it's warmer than normal, then different diatoms will grow in the lake and they will end up in the fossil record. If the climate cools down, then of course you will have diatoms that are more suited to those cooler conditions, and you will find those dominating the sediment layer that you're studying. In other records that we study, we also have studied tree rings. Tree rings are very sensitive to the growth season and also to water availability. So during dry periods, they will actually take up less calcium and also produce less wide tree rings. So by looking at the tree rings itself and the calcium content within those tree rings, we can actually reconstruct rainfall over the life of that tree, which can be hundreds of years for some trees. So this is how we determine climate change using the sediment record or any record like tree rings, for example. And there's many examples, so I can talk to you later about that, but that's it. That is how we do it. Thank you very much for your question, Yuli.
Okay, thank you very much, Pak Henk, for the explanations. And the last questions goes to Dr. Reddy. You have two questions. Please, Dr. Reddy, if you want to respond to the questions.
Okay, thank you very much. In fact, I responded already, so I'm going to I'm repeating. Do you have any idea of application of material combining the COVID outbreak? In fact, I think all people are known that presently we have something like sensors that is again due to the material. For example, nowadays, I think all people are familiar with the COVID. We can detect, for example, you can see some organic molecules are in our. So from there, we can see the people have COVID positive or not. In fact, that is also discovery. Again, if we see that sometimes people want to image processing or sometimes they want to see the cell, again, the materials are going to use it for this particular outbreak. And second question is, still carbon is the future? Yes, I can tell that carbon has a lot of application. For example, you can see the graphite. Graphite is a more dominating. In fact, you can place like Indonesia or India, we have a lot of huge like graphite sources, graphite rock. I think that will play an important role. So, for example, people are looking about graphene. I think they're very hot area. Again, if you want to be graphene sensor, or for example, people want to be fast charging. So that one you can use as conductive additives, including coating or somewhere some conducting mixing, so that we can use the fast means higher current rate we can use. That's why graphene can be used for this particular applications. I think, and also some other question in chat box just now I've seen that. Your opinion, how does the cost of the producing battery recycled material compare those the mines? Is it ecosystem is enough, or must be regulation from the government so that battery waste can be recycled effectively? I think this is a very good question. In fact, I think this is a very important point. So again, the cost of the recycled material compared to those from mining. So again, I think the main issue I told you that quickly I gone through the recycling cost. Presently, recycling cost of the mining is increasing. That's why we cannot throw also. For example, a place like a toxic material, carbon is not a problem. For example, you take about cobalt, nickel, if we throw it in the soil, or again, we are making the environmental problem. That's why irrespective cost, you have to recycle them. That's why it is very important. So, and I think The main issue is economical wise. Presently, I don't tell, because since you have to recover the material again, the cost wise is not really yield is not so good, because if you have 2-3 elements are there, you separate them. Again, the metallurgist, you have to spend a lot of time and energy. I think that is that's why, as I told you that especially government rebates, for example, while buying the battery pack, some money cost of the is including recycling, or parallelly some government has to pay. Why? The reason I am telling that, due to COVID, we suffered almost 2 to 3 years with no air travel. So instead of, for example, losing our economy in terms of different way, I think better way to protect our environment. I think that is very important. So although cost is what I talk with some people, they're telling that we have to spend some other way to reduce the cost, and at least some way you to, example, environment travel. That way we don't have any options. So that way you have to balance our life. It is not like so I think that is very important. It's not like everything we can't enjoy the 100%. So at least somewhere you have to get a advantage, and then you have to use them. Okay. I think the battery recycle, I think government, I think throughout the all the including Indonesia or including any countries, I think since nearly million tons of the metric tons of battery waste is generated, so that we cannot throw it in a waste bin, because they're not what they call as a, not like biodegradable. So it is very important to recover them. I think government has to take an initiative. I think that is very important. Anywhere, I think slowly, I think people, they push some money, especially people are doing with a lot of recycling industry. I think that is very important. Okay. I hope I answered this question. I think again, it will vary. I think we have to adopt, no other option. Slowly, I think that is the way we have to adopt. So don't tell that no. So we have to adopt.
Okay. Yeah. Thank you very much, Dr. Reddy. Any other questions from the audience? Maybe you can just raise hand. Okay. I think there are no more further questions, so we can just stop these sessions. Before stopping this session, I would like to just give short summary. I can summarize that the pandemic is not over yet. Beside of this global COVID-19 pandemic, we still also have another outbreak, monkeypox outbreak that already identified. Although it already identified in 1958, yeah, the first monkeypox patient, but now in Asia is already identified. In Singapore, I see 15 already infected, and also in some other ASEAN countries. And then from ecological point of view, from Spahangs, there are some change due to climate change, environmental change into critical ecosystem, using technique to reconstruct environmental histories over decades to hundreds of years. From material point of view, Dr. Reddy already gave overview that material has many applications, not only for environmental, but also for energy, including generation of bioelectricity from waste, yeah, and also for health, including application of material for combating the COVID-19. And the last presenters show us that conserving biodiversity is very important to secure human security, as well as biodiversity is the basis for sustainable developments. As the chairman for these moderators, I would like to thank you for joining these sessions and also actively involved in the discussion. And I hope you will be enjoying the rest of this conference, and also tomorrow there is another plenary sessions. And thank you very much for all the speakers, Prof. Alfonso, Dr. Reddy, Prof. Hanks, and also Pak Marco, is already not available to present directly. Thank you very much, and I return back the agenda to the committee. Thank you very much. We give applause to all of us.
Okay, thank you very much. Have a nice conference. Thank you. Thank you. See you tomorrow. Thank you.
Thank you, Prof. Hadianto and respective speakers for delivering such a session and well-organized discussions in this first plenary session.
We would like to request our moderator and keynote speakers that are present for today's conference to turn the camera on or to come into the front stage because there will be a certificate presentation from the committee.
First, we would like to give speaker's certificate to Professor Alfonso Javier Rodriguez Morales from Institución Universitaria Visión de las Américas, Colombia. Please turn your camera on, Professor.
Okay, operator, please pin Professor Alfonso for the screenshot. Oh, looks like Professor Alfonso is not in the meeting room, yeah? Okay. Okay, thank you, operator. And second, we would like to give speaker certificate to Dr. M.V. Reddy from Institute of Research, Hydro-Quebec, Canada.
Okay, thank you.
Yeah, please smile. And operator, on my marks.
Okay, thank you very much.
Yeah, 3, 2, 1, and okay. Yeah, sorry. Please give your best smile, Dr. Ready ya? Okay, on my marks, operator, 3, 2, 1. Screenshot, okay. Okay. Thank you, Dr. Ready. And
thank you.
Next up. Oh yeah. Third, we would like to show certificate for Dr. Rekko van Merm from the IUCN Switzerland in the Zoom meeting room. Okay, next up.
Fourth, we would like to invite Professor Hendrik Henis, former FNCA climate project leader and adjunct professor at Undip, to come to the stage and receive the speaker certificate.
We also would like to invite the Dean of School of Postgraduate Studies, Dr. Arbi Sularto, to give the certificate. Okay. Last but not least, we would like to invite Professor Dr. Hadianto, MSc, as the moderator for today's plenary session to come into the stage and receive the Moderator Certificate together with the Dean of School of Postgraduate Studies and our speaker, Professor Hendrik Henis. Once again, thank you for all speakers and our moderator for today's plenary session. Excellencies, distinguished participants, ladies and gentlemen. Now that the main plenary session has finished, we will have a break session until 12:30 p.m. local time. But before the break, we would like to give some announcements.
First, for this parallel session that will be held after the break, participants will present the paper submitted for this conference in a group called class, categorized based on topics that will be presented and discussed. The topics included
1. Cultural and Environmental Development, code CED.
2. Information System, code IS.
3. Energy, code EN.
4. Epidemiology, code EP.
And 5. Environment, code ENV. The session will be led by a moderator in each class, and the list of classes have been written on your abstract book. We would like to suggest all participants to join the class soon after the break session is over.
Second, we would like to inform you that tomorrow, the 7th ICENIS 2022, will be started from 8 in the morning local time. And the agenda for tomorrow consists of main plenary session with 3 remaining speakers, Prof. Dr. Lilam Hong, Dr. A.T.P.G. van Engelenhoven, and Professor Dr. Tri Retnaningsih Suprabhawati MFSC, followed by a parallel session where participants will present the submitted paper, just like today.
Yeah, we hope all participants can attend the conference tomorrow, because as a matter of information, there would be an award for the best presenter in the parallel sessions before the closing ceremony. So please don't miss it.
Last but not least, thank you for today.
Have a nice break and best of luck.